السلام عليكم ورحمة الله. أنا الدكتور خالد طهات فرع الأردن. Today we are going to cover Unit 1 of the course M256 Software Development with Java. The unit title is Introduction to Software Development. Before going to the unit aims, let's have a look at the course aims. The aims of the course M256. First, we start with introducing the software development activities and how these activities are helping us to build a complex object-oriented software. Then we will see the stages of this development, stage by stage, where at the end we will be achieving a working system. Some of your Java programming will be put to work in building systems and complex systems. So in this course we will go back and use some of the skills of object-oriented programming. Go back to our unit we are covering today. In this unit, we try to remind you with some of the fundamental Java and object-oriented concepts, reviewing them together. We will cover some new diagrams like the object diagram, sequence diagrams, which are part of the UML, Unified Modeling Language. We will also have a look at the class diagrams and conceptual diagrams that you have covered earlier in M257. And we will talk about the software development, terminologies, phases, and other related topics. First, we have a look at the main terminologies used in this unit. We start with Java application. Java application, it's more on Java than any other programming language. It's a program that runs directly by the Java virtual machine. Okay, and we have covered that before in M257 and before that in M105. Now we remind you with the term application. Okay. Before we said Java application, now we are just concentrating on application. It's a program that performs a specific function directly for the user, like word processor or Excel or any other applications like web browsers. This kind of application makes your computer looks like a specialized computer to that application. Then the term software system, or sometimes we use that term system or software, which is a bigger program than the application, and it covers many tasks, much more tasks than the one in the application. Of course, as you know, all those applications and systems or software systems all built in high-level languages. And in this course, our high-level languages that we are using is Java language. And the term system code means the high-level language source code that we used to build our system in. In this course, we are going to use the integrated development environment NetBeans. NetBeans is not new for you. You have learned and used it before in 2 courses at least. And you know all the features of NetBeans. Some of them is listed in this slide. Now we remind you with some of the basic concepts of object-oriented programming. In the heart of these concepts is the concept of an object. An object is built of a collection of data and operations. Sometimes you call them attributes and behaviors. And the attributes or the data in the object can be implemented using variables, where the operations is implemented using methods. All objects that have the same attributes and same operations are said to be of the same class. So this class will produce objects that are identical in operations and attributes. And this is a very basic concept that has been covered before. We start with exploring a diagram that will be very important for the rest of the course, which is the object diagram. The object diagram is a diagram that will be used and normally used to illustrate objects and links between these objects. It will be represented by rectangles, and as you can see on this slide, you'll have the object name in the higher compartment of the rectangle, where the rectangle is divided into two compartments, and in the lower compartment of the object diagram you will have the specific information about the attributes of that object. We call it the state of the object. And you can see in this diagram that we have the object bubble tree. It has the name Rosie Webster and a date of birth in some particular format. As we mentioned earlier, there's always a relations between the objects, and that's how real life runs. Objects in the real life are related to each other. And in this example, we can see that the object bubble 13, whose name is Rosie Webster, is linked to form 2. She is a member in form 2, and that form 2 is taught by a teacher, teacher 6, Mr. Barlow. So bubble 13 named Rosie Webster is linked to form 2, which is named form 1B, taught by teacher 6, whose name is Mr. Barlow. So this illustrates and shows the relations between the different objects in this system, and you can see the links between these objects. Of course, in form 2 there will be more students besides Rosie Webster. All of them are taught by the same teacher. So this is part of the object diagram in this system, but if you want to add more, you can add more links to form 2, and you'll have bubble 1, possibly 2, 3, 4, 5, and all the objects can be shown in this diagram. Now, in the real life and in object-oriented systems, as you have learned before, objects communicate and interact within the system. They interact, they cooperate to be able to perform some task. How do they cooperate? They send and receive messages. So by sending messages, objects can cooperate, can interact. And in object-oriented programming, we call this messaging invoking of methods, or sometimes you call them calling methods. Now, there are more diagrams to show us the exchanging of messages, and these kind of diagrams, we call them dynamic diagrams. A very good example of these diagrams is the sequence diagrams. They show us the objects, how the objects are interacting, how the objects are cooperating using messages. Now moving to the sequence diagram. Sequence diagram is representing objects but in a different way. In object diagram, the object diagram shows the state of part of the system at some particular time, which means it's a static, and it's part of the static model in UML. In sequence diagrams, the full interaction between the objects is shown, considering the time, and it's part of the dynamic model in UML. So it shows the steps of objects interaction. In this diagram, we show a simple sequence diagram where you have three objects: user interface object, school, and form 2. And you can see that user interface is sending a message to school, and later maybe the school will send a message to form 2 or give back a feedback to user interface. So you can see that one step is coming after the other, considering the time and making this interaction dynamic. More on sequence diagrams. As you can see now, we have labeled for different parts of the sequence diagrams. In sequence diagrams, each object is represented by a rectangle. As you can see, user interface, school, form 2 are all objects, and each is represented by a rectangle. And the rectangle includes the identifier of the object, means the name of the object, and as you can see, it's underlined. On the left side, you can see the time is viewed as running vertically downwards. So get all set bubble of form 2 as a message comes first, and the coming messages will come after this message, considering the time running vertically downwards. The dashed line vertical line, the dashed line coming vertically down from the object represents the lifeline of the object. As you can see in the school object, there's a dashed line coming down, and that dashed line represents the lifeline of the object. When the object receives a message, as in case of school object, an activation rectangle running vertically downwards is started on that object lifeline. Means this object is active now because it receives a message or it's sending a message. The message is represented by a solid line. As you can see, the message between user interface and school, there's a solid line representing that a message is sent from one object to another. If we see a dashed lines, we will see it in different and coming sequence diagrams. The dashed line represents the feedback. So a message will be a solid line where the dashed line represents a feedback. Here is the details of the interactions in case of sequence diagram. If you look at the sequence diagram here, you'll find that more messages are sent between and among the objects. School object is sending the message get oldest bubble to form 2. And if you consider the time, you find that the new message is coming after the previous message from the user interface to the school. Now more messages are exchanged among the different objects, and you can see that we have solid lines represented by the methods and dotted lines representing the feedback between objects. Now in this diagram, the full interaction between the objects is completed, and you can see that the interface now is receiving some results. Now we move on with the development phases and models. Now we remind you that Java is the language to be used in this course, and Java is an object-oriented programming language. And as you have learned before, Java has some basic features like being able to build classes in Java. And as you learned before, a class is a blueprint where we define common attributes and behaviors that will be part of the object, or the way the object is going to behave. Now, the object-oriented programming languages, including Java, has a very important features called inheritance, okay, where the class is representing a special kind of another class. Like we say, for example, person, and a special kind of person is student or policeman. Java allows you to build this kind of relation and definition of classes. Of course, now to be able to have some communication between the objects, you need to have messages, as we have shown before in the previous slides. And the message will allow objects to cooperate and to interact. And at the end, the task will be completed by this kind of interaction and cooperation. To be able to protect our data, we have the feature called data hiding, where we can protect our data from unneeded or unwanted access from different other different classes in the system or other objects in the system. And as you may remember, we have the access specifiers: public, private, protected, and package, that will help us hide our information at different levels. Also, the polymorphism is a very important concept in object-oriented programming languages, and this feature allows different classes to respond to the same message in a manner appropriate for each class. So each class will respond differently for the same message. Now, in software development, classes are very basic thing, and they are the factory for objects, and objects at the runtime will cooperate to achieve and perform some task. Now, such complex systems like object-oriented systems and real-life systems that we are seeing and building and experiencing nowadays needs a good management when building them. So we need to manage the development of building the software in a very good way, in a very systematic way, suitable to tackle this complex situation. And to be able to do that, we are going to use development methods that goes into phases. And in this course, we are going to introduce the basic phases of software development lifecycle. We start with the requirement specifications, which involves eliciting and analyzing the user and the client requirements. Then the conceptual model will be developed, and basic classes and connections between classes will be developed during this development, considering the real-world area of the system to be built. After building this part, which is considered as a static part or a static model, as we've seen in the object model, we will move to the dynamic models, where we will build the sequence diagrams that shows the interaction between the objects to be able to perform the task. And part also of the development is to build the user interface. And as you saw before, in sequence diagrams, we build the sequence diagram by using a user interface object, and by going through all the development phases, we will be able to build and represent the complex system in a successful way. Further, we go with the detailed design and implementation. So in the conceptual model, we discussed only the basic design and the conceptual model. Now we go to the detailed design. And when the design is completed and implemented, we will test our implementation to ensure that we have completed the user requirement and we have met the user requirements. After the testing, the deployment of the system to the client will be done, and we need to continue maintaining our software that we have deployed in the phase we call it maintenance, which is a very important phase to keep the system working and to keep the system satisfying the user needs. It may include fixing emerging problems where we have problems to be fixed, or if there's any small changes to be done with the system, we call it fine-tuning of the system. It will also be done during the maintenance, and if the user is requiring enhancing for part of the system or the facilities of the system, then this also will be done in this phase. It's important in software development to model our ideas. So in software model, we change or map our ideas into models. And example of the models is the sequence diagrams that we have seen earlier. So to make the idea clearer, to make the idea in a form that can be enhanced, that can be understood by your team and maybe later by yourself, we need to move or map this idea into a model. In this course, the UML, Unified Modeling Languages, will be used to model our ideas at different stages. UML is very important, very strong modeling language. The standard of this language is set by a very important organization called Object Management Group, OMG. In UML, you have many diagrams that can help you building your system in the right way at the different stages. We have mentioned object diagram and sequence diagram. You have learned also about class diagram and activity diagram and more diagrams that can help you at the different stages of your development. UML is very important modeling language, very common in the academia and industry. Depending on the system that you are developing, you have to choose some development method. So the phases we have mentioned earlier are all common phases in software development, but there are some methods which use some particular set of phases. And these set of phases are applied in some particular order. So the phases mentioned earlier can change in the order or the importance based on the development method. One of the very famous development methods is the waterfall method. It's a traditional, old, idealized view of software development. And as you can see, in this development method, you go from one phase to another, and each phase is visited once only. And when one phase is completed, you cannot go back to that phase. Waterfall method of development, of software development, is useful in some situations and good in some situations, but it's not suitable in some other situations. Basically, when your software requirements are well defined, then waterfall method of development can be useful for you. So if you are very clear about your requirements, you know all the details, or you have someone who knows all the details about your system in all phases, then you can use waterfall method of development. But if your requirements are ill-defined, not well-defined, means ill-defined, not well-defined, and you have some ambiguity, or in some situations you are not sure of your requirements, then you are not advised to use waterfall methods. After all, in waterfall methods, you will not be able to know the results only at the end of the development, where it will be too late to do any change. Now, when the development are well defined, then you will see and feel the advantage of the waterfall method, and your work will be very fast, and you will not have many tries to get your task completed. In the other case, when your requirements are ill-defined, not very well-defined, then you will face a lot of problems with waterfall, so you have to look for different development method. The disadvantages of this method are listed here. It doesn't produce a working system until the end, so you won't be able to know how good is your development. You will not be able to know and test your artifacts you are building only at the end, and you will not be able to know your errors only at the end. This method doesn't allow you to change your requirement during the development, which is sometimes very important. Some systems change requirements during the development, but if you are using waterfall, you will not be able to do that. You will not be able to go back to a previous phase for any reason. You have to continue, and only at the end you will know how good or how bad is your achievements. Now, if you find that waterfall method is not suitable for you and your requirements are not well defined, then you have to look for a different method. And one of the famous methods that we always use is the iterative method. From the name, iterative means repetition, so you can repeat iteratively in a systematic manner, means you can go back and change in some previous development that you have done. One common technique or mechanism used with iterative methods is a prototype, which is an early working version of the system or part of the system. You can use this version to test your ideas, to confirm your ideas, and then if you find that your idea is not good enough, needs development, you just can change it and try it again on the prototype. When you are sure of it, you can always go on and develop it. And in case that you need to go back to some previous stage, as you can see in the diagram, you can always go back to that stage. On the other hand, you can build your system up of subsystems. Means you take one subsystem, build it, and then go into another iterative, another cycle, and build the other subsystem, and integrate the two subsystems together to have a bigger subsystem, and so on. So this will go with the, say, divide and conquer. Means you can divide your system to subsystems, and you use the iterative method to build these subsystems individually, and then you can combine them together to have your system. This slide shows us the software development course and the dependencies between the different chapters. Building software systems in the current time is very complicated, as we mentioned earlier, and to be able to succeed in building such systems, you need a team of IT specialists to be able to help you. At least the team will include the roles we have on the slide, as you can see: systems analyst, requirement analyst, designer, programmer, technical writer, software tester, and project manager. Now we have a look at the duties and the skills that each of the team members should have. First, system analyst. He must be a technical expert in software systems. He will need to analyze the feasibility of the proposed system and evaluate how it may fit into the client's business. So it's a very important role. Now we move to the requirement analyst. Now we decide that this system is visible, and we have identified how this will fit with the client's business. Now we will start working on the system by collecting the requirements. And collecting the requirements has many methods. We can collect requirements and data about the system using questionnaires or interviews or observations, or sometimes you can refer to publications on the field. Different ways to collect the requirements. It's very important to interview the client, to listen to the client and learn from them what do they want, what do they expect in this system. You may talk to the users, or you may use a questionnaire to collect information from the users. Now, after collecting all this information needs to be analyzed, and we need a requirement analyst who will be able to illustrate and analyze this requirement and give us an idea about what are the functionalities of the system, the functional requirements of the system, the non-functional requirements of the system, the user needs, the constraints, and many other things. These things will be covered during the course, but this very important role is very essential, and we need a very good requirement analyst to be able to build a successful system. After the requirements are clear and analyzed, the designer will come to put these requirements to work. And the designer will help us. There possibly can be more than one designer, because we have user interface design, we have engine design for classes of the system and the engine of the systems, we have database design. So the designer or the designers or the team of designers will help us designing the different artifacts and stages of the project. When the designs are ready, we need this design to be implemented and to be coding using the programming languages of choice, and in our case it will be Java language. And this code, when it's built, when it's implemented, needs testing. and we will learn about different types of testing during the course. We start from the unit testing, means we test small pieces of code, and then we go to integration of those units, and at the end we will have our overall system tested. That will be done by the programmer. Now, this complicated work needs to be documented in a very good language, a clear language, for us as a team in the future to know what we have done and to remember what we have done, and for other people who may continue the work or maintain the work or involved in a way or another with the work. So we need a technical writer who will build our user documentation, help files, user manuals, and maybe sometimes write some documentations within the code. This is very, very important to be able to understand complicated systems. Otherwise, things will be hard for users to use, for developers to improve, and sometimes for even the people who build the system to maintain it. Now, the programmer has done some small tests, but if you want to have an overall test of the system, then you need a software tester. A software tester will take time to be sure that the system is validated and verified. And these two important concepts will also be covered in Unit 10. Now, a team needs a leader, someone to manage the project, to plan and oversee the running of the software development, to make initial assessment of risks and take actions against these risks. Someone to be responsible and take decisions and communicate with other stakeholders, including clients. As you can see in this slide, you may read a key factor of successful project is having a good communication between the different people involved. And much of this communication is in the form of written documentation. So we have a team who is developing the project, we have clients, we have other agents, and to be able to communicate with those people, we have to have a good documentation of the project. This is the only way that we can show and discuss and communicate our ideas. So we need a project documentation, which is a written description of activities, decisions, and outcomes of the phases. So what are the activities? Who will handle those activities? What should be the outcome of these activities should be documented. Decisions taken from different roles, different members of the projects, different stakeholders also need to be documented. The deliveries of each phase. We have phases of software development. At the end of each phase, there will be a delivery, something to be produced out of this phase, to be taken to the next phase. So these deliveries, the outputs of the different phases, should be documented and passed to the next phase and people involved in the next phase. Not only this, maintaining the system needs a very good documentation. When some people come later, maybe after years, maybe less, maybe more, if they want to maintain the system, they need some documentation to tell them what have been done with the system during the development or in a previous maintenance stages. As I mentioned earlier, models like sequence diagrams, class diagrams, codes produced, decisions taken, all need to be documented. And this is a very important thing to be done for every software project. A very important part of the documentation is a program documentation. And these program documentations are comments within the code, and comments produced as a result of running some software like Java doc program provided by Java SDK. To make things clearer, I will elaborate. We have two levels of program documentation within software. Both are very important, and both are essential to be able to use classes, either by the development team of the classes or the system, or by future users of these classes and libraries. The first type of these documentations is comments that facilitate understanding how the software is implemented. So within the code, you'll have some comments to explain what does this program do? What does this method do? Why this variable is used? Why this return data type is used, and so on. And this is very important to be able to understand the code itself. Now, if I'm providing a library or a class for someone else to use, which is a very important feature in object-oriented programming, reusability. Reusability means you build software, classes, artifacts that can be reused. So how the people are going to use it if you don't give them some information about it? So you give them some information, make them understand what does the system do and how, or the class do, or the artifact do, and how to use it. And this is very important. If you are a Java programmer, you sure have come to learn that there is some Java library documentation. If you take any class in Java, take for example string class or any other class like interface classes, button, text field, text area. Now how to use these components? There's a documentation for each and every class in the Java library. You can go to that documentation and you can learn about how to use the class, what are the constructors, what are the methods, what does the method take as parameters, what does the method return as data type, how to use this method in the right way, or how to use this class in the right way. This is very important for every Java programmer to learn and to be able to use the class documentations and to produce these kind of documentations. In this diagram, we can see the two types of documentation that you may find in your Java program, and later you are required to add these comments to your program. In the first case, you can see and read returns the teacher with the most bubbles in their form. This kind of comments describes what the method does. So when you read this comment, you know that the method does so and so. And in the future, you think about yourself always describing a classes that you are building, what they are doing, and the methods that you are building, what they are doing, and how to use them. In the second case and the second arrow, you can find that the comment is describing how the code works. So it says, I iterate through all forms. That's how the work is done. And the method will iterate through the forms using a for statement. Last but not least, we will cover a very important term which is called CASE, Computer-Aided Software Engineering. As we mentioned earlier, we are building very complicated systems. We need a lot of help as a team and as individuals from the computer systems, the computer software, to be able to do our work. We need help to be able to write our code, as in case of using NetBeans. We need help to be able to draw our diagrams, like UML diagrams. We need help to be able to document our work. So we need tools at different stages. Very importantly, we need tools to help us testing our software. So the CASE stands for computer-aided software engineering, which is tools that we help us at different stages of our development. Just in the previous slide, we learned about the Java doc, which help us documenting our code. Other very important tools that we use, and these tools will ease our life when developing such complicated software, is design tools. And basically they are UML based design tools, and you'll find many of them available on the internet for free as open source tools, or some are licensed tools. They're very important. They help us drawing our object diagrams, sequence diagrams, UML diagrams, deployment diagrams, and so on. That will be in the case of analysis and design. In case of coding, we also have the IDEs, and our NetBeans is one example of them. You can find other like Eclipse and many other IDEs that help you coding your design in Java language, and you will find other tools for other programming languages. Now, after building our program, we need to test it, and as we said, especially in case of iterative development method, we are building our system in phases and in cycles, and we do small testing for small pieces of code, then integrate them into bigger pieces of code, into subsystems, into overall system, and we need to continue testing our system on all these phases to be sure that we are running it the right way. So testing tools, they help us in testing, and very important tool, we call it the JUnit, is an example of these tools. JUnit will help us testing small units like classes of Java code. In this course, we are going to continue with learning about software development. We are going to use modeling languages, programming languages, and show how the complexity of systems can be tackled. There will be very good ideas, very good things to learn about software development in this course and in the coming unit. Today, we have covered Unit 1 from the course M256, and in this unit, we reminded you with the fundamental Java object-oriented concepts, and we give you a clear idea about how basically we may tackle the complexity of software systems using the different tools, using different techniques, building teams to be able to do that. We introduced some of the dynamic model in UML, object model, diagrams, and sequence diagrams. We have learned about the development phases and the development method. Until we meet in the next unit, thank you. Wassalamu alaikum wa rahmatullah wa barakatuh.